All right, and welcome to domain and range of inverses level 1. Now in example 1 it says find the domain and range of f inverse of x for f of x equals 2x plus 1. Now my first question is, what type of function is this? Is it linear, quadratic, exponential, rational, square root function, cube root function, cubic function? What kind of function are we dealing with? And the answer is, whenever our exponent, our highest degree, is a 1, well, we know that this is in fact a linear function. Now I want to give you basically just a very generic graph. What does a linear function look like? Well, a linear function could look like this. All right. And remember, when we talk about the domain and the range, we're saying, well, how far to the left or right, or how far down or how far up is it going? And so let's discuss this. Remember, left and right is the domain. And when you look at this white line, how far to the left is it going? Well, you'll notice it's never going to stop going left, so it's going to the left, negative infinity. So it's our domain is from negative infinity, comma, and how far to the right is it going? Well, it never stops going to the right, so we said, hey, you know what, it's headed towards positive infinity. Now, this is one way to say negative infinity to positive infinity. Another way to say it is the domain is all real numbers. And while you might know this as the hashtag, this is the number symbol. Okay, let's go ahead and speak about our range. Well, our range is very similar for a linear function. Okay, we see that this line is forever and always going down, so it too is headed towards negative infinity. And as we go to the right, it is forever going up, so it's going towards positive infinity. And of course, we can say that, well, this range too can be written as all real numbers. So before we dive into this problem, I just want to say, anytime you have a linear function, the domain and range is easy. It's just all real numbers. And even the same is true for its inverse function. Okay, let me demonstrate. Here we have our xy axis. And let's go ahead and graph this function here in orange. We know the y-intercept is 4. 1, 2, 3, 4. And we know that we have a slope of 2 over 1. So we'll go up 2 and to the right, 1. Or I could do the total opposite and go down 2 and to the left 1. And our graph will look something like that. Okay. And you'll notice that the domain and range of this is all real numbers. It goes to the left forever, it goes to the right forever, it goes down forever, it goes up forever. Now, what about f inverse of x? Well, remember, to find the inverse function, we change f of x into y, and we'll say y is equal to 2x plus 4. And from here, we know that in order to get the inverse, we take our x and our y and we switch them. And so now x is equal to 2y plus 4. From here, we know that we want to get the y by itself. We get rid of our addition first, and we simply have x minus 4 is equal to 2y. That zeroes out. And lastly, we know that to get the y by itself, we'll divide both sides by 2, and that cancels out. And remember, we're going to take y, and we're going to write it as f inverse of x is equal to, and notice that's really 1x divided by 2. I can write 1 over 2x, and that's really negative 4 divided by 2, which is negative 2. Now, if I were to graph this, and let's go ahead and graph it in this, let's go ahead and graph this in green, I'd say, well, negative 2, that goes down 2, and my slope is 1 over 2. Okay, and I could go up 1 and to the right 2 again, and my function will look something like this. Well, the inverse of a linear function is still a linear function, so what are we going to say? We'll say, you know what, our domain is from negative infinity to positive infinity, and we'll say that our range is from negative infinity to positive infinity. Guys, I'm only going to do one example for linear functions because the domain and range is easier. For f of x and f inverse of x, it is always going to be negative infinity to positive infinity, or all real numbers. All right, thank you all so much, and I'll see y'all in our level 2 video.